Hey guys, it's been quite a while. We watched the previous video, and the delay is because I was really busy with something else, something personal. But nevertheless, what I'm gonna do is that from now on, I'm gonna keep on recording regular videos, and you're gonna get regular updates from Developedia. And hope uh, hope guys you're really gonna enjoy today's video as well. And our today's video is also going to be on one of the dynamic programming problems. And this is commonly known as egg dropping problem. This is a very common interview question asked in many companies like Uber, Amazon, Google, Facebook, many companies. So let's take a look at it. And now, you guys know what we actually do. We first go through the problem statement. We try to, break the solution into parts and try to understand the subproblems, how we're gonna solve it. And after that, we go to the code section. So this is gonna be no different from the other videos. This is gonna be similar to that, and hope you guys enjoy. Now, yeah, let's start. So this is our problem statement. So it says that given a certain number of eggs and a certain number of floors, so these are the eggs you can see and these are the floors you can see of a building. Now, how many minimum number of drops you need in order to identify the lowest floor wherefrom if you drop an egg will break? So it means that, let's say, if you drop an egg from, let's say, this floor, so 1, 2, 3, 4, this is the fourth floor. So if you drop an egg from the fourth floor, what will happen, whether or not it will break? So let's say if you drop it from this floor, it will break. So what it means is that the first floor from where if you drop an egg will break is going to be lesser than or equal to 4. Because if you drop it from the third floor, it may break or it may not break. But if you drop it from the fourth floor, it will break. So what it means is that you're going to have to find the first floor, and first I mean from bottom to top, all right? The first floor wherefrom if you drop an egg, it will break. So this is the problem statement. I hope the problem statement is clear. If it is not clear, please feel free to pause the video, rewind, watch it again, and I hope you'll be able to understand. Now, we're gonna go to the solution part. You may pause the video for a while to think of a solution, and then you may come back to the video and just see if your solution works or not. Now we're gonna make a few observations in here. So the first is that if we have 0 floors, what it means is that if we do not even have a building, all right, then what? Then we don't really have to drop an egg, because if we don't have a building, then where do we drop the eggs from? There's going to be nothing to drop the eggs from, right? So therefore, the number of drops is going to be 0. Secondly, if the number of floors is 1, then we need to drop an egg only once. What it means is that from the one floor, that is the first floor, wherefrom we need to drop the egg and check whether or not it breaks. If it breaks, we can say that this is the floor number 1, wherefrom if you drop an egg, it will break. And if it doesn't break, then we're going to conclude that if you drop an egg from the floor number 1 or the first floor, it ain't going to break. And that's it. You don't really need to iterate over and over again for something more iteration or something. It's not required because you just have one floor. On the other hand, if you just have only one egg, then the thing is that you cannot apply your intuition. You cannot, be really, really intelligent and make some kind of processing and make the process efficient. You cannot just do that. You're just gonna have to iterate from the first floor, then second floor, from third floor, then fourth floor, like that. Because if you drop an egg initially from this floor, topmost floor, and if you see that it breaks, right? Then what are you gonna say? What is the first floor wherefrom if you drop an egg will break? How are you gonna identify that? You don't have any eggs left, right? If you have any eggs left, you can try from this or this or this, whatever you want. But if you do not have, you can say that, if I drop an egg from this floor, this will break. But I don't really know which is the first floor wherefrom if you drop an egg will break. So you're not getting the answer. So what you're going to have to do is that you're going to have to iterate from the bottommost floor to the topmost floor. And so therefore, if we have only one egg, then the number of drops is going to be equal to the number of floors. Now what do we see here? If you have 0 floors, then the drops will be 0. If you have one floor, then the drops will be 1. And then if you have one egg, then the drops will be equal to number of floors. From these three combining, we can say if we have 0 floors, or if we have 1 floor, or if we have 1 egg, then in these cases, the number of drops required is going to be equal to the number of floors. I hope this is clear, because 0, in this case 0, 1, in this case 1, and in this case you're getting directly as the number of floors. So this is going to be a base case of our dynamic programming, or whatever. Now let's make another observation. Now let's say you have eggs, you have, let's say, E number of eggs, and you have some floors in a building, and you have and what is the number of floors you have is the total floors. Let's say this number is this, and this is the floor number F. Let's imagine F is some number which lies between 1 and total floors. All right, and this is a ground level. All right, now what will happen if you drop an egg from this floor F? One possibility is that the egg is not going to break, and the other one is that egg is going to break. Now, if this egg does not break, then what? It means that if you drop an egg from this floor number F, it won't break. Then what does it mean? If you drop the egg from any floor below this floor number egg, it won't break either, because the impact is going to be even smaller. So you're going to have to drop it above floor F. So you're going to have to look above Fth floor. And then the remaining number of floors to look into is going to be total floors minus F, because that is what number of floors you have on top of this Fth floor. And then the remaining number of eggs to work with is going to be E, because you didn't really break the egg, so you have all the eggs in your hand, and therefore you're going to have E eggs to work with. Now what happens if the egg breaks if you drop it from Fth floor? It means that F is a floor wherefrom if you drop the egg, it will break. It means that the minimum floor, the closest floor to the ground wherefrom if you drop an egg will break, is going to be lesser than or equal to F. So what you're going to have to do is they're going to have to look below the Fth floor, not above. Why? Because you're going to have to minimize the impact and see, does it break? Does it break? Like over and over again. And there's going to be an algorithm for doing the same. But the thing is that you're going to have to look below the Fth floor, because it breaks if you drop the egg from the Fth floor. Now, what the remaining number of floors you're going to need to look into is going to be F minus 1, because these are the number of floors you have below the Fth floor, right? And how many remaining number of eggs you're going to have to work with is going to be E minus 1, because you already broke 1 egg. So you're going to have 1 less egg to work with. So it's E minus 1. Now if we minimize the entire thing and try to get a mathematical picture of this, we can say that this part, we can call this get min egg drops. Let's say this is the name of a function, and we're going to call it a function method, whatever. And we're going to call this is a function of E and total floors minus F, because we're going to need to look above this, right? So when you're looking above this, we have E eggs to work with, and the number of floors we have to work with above this is going to be total floors minus F. So let's say this is the function which takes 2 arguments, number of eggs to work with and number of floors to work with. All right? Similarly, if you try to mathematically formalize this thing, this is going to be something like this. Min egg drops of E minus 1 and F minus 1. Because E minus 1 is the number of eggs you're going to have to work with. And F minus 1 is the number of floors you're going to have to work with when you're looking this side, the below the Fth floor. Alright? And now what you're going to do is that you're going to take the max of these 2 values and you're going to call this thing as drop of E comma F. What it means is that drop means the value of, a minimum number of egg drops you're going to need if you drop an egg from floor F. I repeat, this drop comma E of F, drop of E comma F is going to be the minimum number of egg drops you're going to need in the worst case if you drop an egg from the Fth floor and you initially have E eggs to work with. Now, why are we taking the maximum? Why not minimum? This is because we're gonna have to consider the worst case, because you cannot just assume the best case and just go on working with it, because the best case might not happen in the worst case. So you're gonna have to consider the worst case, and that's why you are taking the maximum drop of EF. This is the value we are denoting as the, you get it right, the minimum number of egg drops in the worst case you're going to need if you drop an egg from the Fth floor and you have EX initially to work with. Now here's the thing, we just did this for this just single floor, right? Now, in order to make this a dynamic programming solution, we're gonna have to iterate through all the floors and take the best possible case. That's why what we're gonna do, we're gonna repeat this for all floors. And the for loop is gonna be F is equal to 1 to total floors. This is the 1 and this is the total floor. F is gonna iterate from this to this, and we're gonna take the minimum of drop of EF. That's it. And why are we taking the minimum? Because in this case, we are taking the best case, right? Now you may ask, why are we taking the best case? See, if you take a look at the problem initially, this is that you're gonna have to identify the minimum number of egg drops you need, right? How many minimum number of egg drops you need in order to identify the lowest floor, right? So you're gonna have to minimize the drops. So you're gonna keep on doing this thing until you find the minimum drop. So therefore, this is your main problem. Get min egg drops of E and total floors. What it means is that initially you have E eggs to work with and you have total floors, number of floors to work with. This is your initial condition, and this is where the program execution is going to start. This is your recursive steps. This is your problem. These two are your subproblems. And you have the base cases as where egg is 1 or floors is 0 or floor is 1. Now that we have a pretty much good understanding of the problem, now we're going to try to code it up. And if you think that you have any doubt or any difficulties in understanding any part of the video, just pause the video, rewind the video, and watch it again. I hope it is going to be clear. And if you still do not understand, you can comment down below and I'll try to respond to it as soon as you can, all right? All right, now let's take a look at the code for this. So this is our problem. Let's say we have 3 eggs initially to work with and we have 15 floors, all right? Now, and we are calling this function get min egg drops of eggs, floors, and we are printing it. So what this function returns is the minimum number of egg drops required in order to identify the lowest floor wherefrom if you drop an egg, it will break. So this function does the following thing. The base case is that if eggs is 1 or floors is 0 or floors is 1, return floors, because this is what the minimum number of egg drops we are going to need in the base case, right? Now, this is the recursive step, but before going into the recursion, we're going to need to check in the memo first whether or not it has already been computed before. If it has already been computed, then we're not going to compute it again. We're just going to return it from the memo. Otherwise, we're going to have to compute it. So we're going to use this thing, a string key and get key of eggs and floors, and this get key does nothing. It just converts this integer to a string and then adds a space in between, and then it adds this integer again. So this is going to be eggs space floors. This is going to be the key in this string format. Now, why am I doing this and not using this? Not using just a map or something like that and use a pair of int comma int. The reason is that the map is implemented in tree map format and the unordered map is implemented as the hash map format in C++. Now the thing is that if you use map, it's going to make it search inside a tree, and that is going to incur some kind of complexity, and that won't be the search operation inside that memo, if it had been created with a map, would have been O of log n, not O of 1. But since we are using this as unordered map, this is a hash map, and therefore the complexity will be O of 1. This is constant time complexity. All right. Now, once we have the key, we're going to see that if the key is present in memo, and if we see that it is present, then we're going to return the key from the memo. And otherwise, what we're going to do is that we're going to compute and store in memo and return. So we're going to initialize the key as int max, and this is nothing, this is just plus infinity, and this is just a value with a very big number, and we are initializing this to int max because we're going to have to take the successive minimums over and over again inside the for loop. So when you have to take this as a max, you can initialize this as int min. And when you have to take successive mins, you're going to initialize it as int max so that this initial value does not come into the picture. Because just think, if I had initialized this as int min, all right, then this value would always remain int min no matter what. Because whatever you get in the right hand side of the min function will never going to be minimum from int min. So this value won't even get updated, and we won't get the whatever the value we really are looking for. So we're gonna initialize this as int max. So after that, what we're gonna do, we're gonna do the for loop, and we're gonna iterate from floor 1 to floors. Floors is the total number of floors, and this is a floor plus plus. And then inside this, what we're gonna do, we're gonna take the minimum of this and this thing. Now what is this? Let me explain this. This is get min egg drops of eggs minus 1, floor minus 1. This part is when our egg breaks, right? So this is our this part. This one. Yeah. This is our this part. When the egg breaks, then it's going to be get min egg drops of e minus 1 and f minus 1. This is the same thing. Get min egg drops of eggs minus 1 and floor minus 1. And this is the case, this thing is the case when the egg doesn't break. Alright? Then in that case, you're gonna have to look up, right? Not down, up. So therefore, when you look up, the number of eggs you have to work with is e, and number of floors you have to work with is going to be total floors minus the iterating floor, which is f in this case and floor in this case, and you have the total number of floors as floors in this. So this is going to be eggs of floors minus floor, and you're taking the maximum of this in order to get the worst case. Now what is this one for? See, if you have to do this thing, right? If you have to check whether or not the egg breaks if you're dropping it from here, then initially you're going to have to drop it once, right? Because unless you drop it, how are you going to even know that whether or not if you drop, whether or not it's going to break? So you're going to have to drop it once, right? No matter what the result is going to be, if it breaks or it doesn't break. So for that drop, you are adding this one to this max value, all right? And you are taking the minimum of all these things, iterating from floor is equal to 1 to floor is equal to floors. That's it. And you are returning this from the memo. And that's it. Now we're going to execute it, and let's see what result we get. Drop dot cpp 5. All right. Now 5 eggs is 5 is the minimum number of drops you're gonna need if you drop this egg from this. All right. Now let's take a look at the Python code as well. So it does the same thing. Just the difference is that instead of using an order map, we are using a dictionary in Python. And Python does this thing in O of 1 only. This is a hash map kind of thing. Is implemented from inside, and that's why we don't really need to convert it to string, and we can just do it directly like this. And we can just use it memo of tuple, and we're gonna pass the eggs comma floors in here. And this is the same logic we have implemented in the Python. And even if you execute the Python function, you're gonna get the same result. It should be 5. Let's see. Yeah, 5 it is. Yeah, it's correct. So I hope this is clear. Now you may pause the video, and this code I'm gonna upload it to GitHub, and this code is gonna be available in the description, and you can take a look at this. You can fork it, you can do whatever you want, and now that we have these things clear, let's take a look at the complexities. So what is going to be the time complexity? As we know, time complexity of a dynamic programming solution is number of DP states times the time complexity of the recursion. Now what is the number of DP states we have in here? Let's see. Number of DP states we have is, you know, in this function, we are passing this function method, whatever. We are passing this thing, eggs and floors. Therefore, the total number of states is going to be eggs times floors, right? And what is the complexity of each recursive step? If you see this is O of 1, this is O of 1, this is O of 1, there is you have a for loop. And this runs from 1 to floors. So therefore, this has a complexity of O of floors. So if you take a look at this, E times F is the number of total DP states because this is eggs and then floors. So E times F for that and times O of F for this for loop, right? For this floor. So O of F. So therefore, the total time complexity of this problem is O of E times F squared. Now, what is the space complexity for this? The space complexity is going to be the space complexity of the memo. What is the memo? This thing, right? Memo in Python, you can see this is the dictionary. Now, how many number of entries are there going to be inside this memo? The number of entries are going to be the number of times this memo is called. In other words, the number of keys present inside this memo. All right? Now, what are the number of keys that are present inside the memo? This is going to be the number of states in the DP and minus the base cases, because we're not going to insert the base cases into the memo. We're only going to use the recursive cases inside the memo. So whatever, the base cases are going to be constant times anyway. So therefore, I know the complexity of the space complexity of the memo is going to be O of the number of states, which is eggs times floors. That's why we have the space complexity as E times F, x times floor. Now that's it for this video. With this, we come to the end of this video. I hope you enjoyed this video. If you have any doubts, any comments, you can just leave it down below. I'm gonna be glad to happy and glad and happy to answer your comments. And yeah, and please like and share this video and subscribe to Developedia for more amazing contents. And I promise you guys that I'm gonna keep uploading videos like this from now. So hope you guys enjoyed and see you in the next one. Peace.